Okay, here we want to calculate our delta H for the conversion of graphite to diamond. We're given the central equation there that graphite, which is a form of, there's two forms of carbon, and it's graphite, which we know is soft, black, slippery material used in lead pencils. I use lead in quotes, and also we use graphite for lubricants. And there's then diamond, the brilliant hard gemstone. And we have our thermochemical equations here that are given to us. And of course, in a thermochemical equation, you also have your delta H's included. So let's take a look. That's what we're given. Given are these carbon graphite plus the oxygen is going to CO2 gas, and carbon diamond plus oxygen is going to CO2 gas also, and their respective delta H's for each of them. So we want to get the overall equation. So what do? Well, remember, we're going to use Hess's law here. So we need to flip one, multiply one if need be. We can do all of these as a mathematical consequences of it being a state function. So we want to get it so we have the above grand equation, if you will. So if I take a look at that, I want diamond on the right side. Diamond on the right side. So that would mean, let me change color here. That would mean that I want this one, all right, to be flipped. All right, so I will flip that equation, but when I flip it, then I also need to change the sign. So I end up getting C, that's my graphite. I'm going to write them all out. Graphite, and that's a solid, plus my oxygen, going to CO2. So nothing has changed in this first equation. And my delta H here is equal to negative 394 kilojoules. Now the second one's the one that I have flipped. So I end up getting CO2, which is a gas, and that gives me C diamond. All right, I'm just going to put it like that, dione, all right, because I'm running out of room. That's a solid plus O2, and that's our gas, and then our delta H for this is, well, remember, we changed the sign, so it would be a negative 396 or a plus 396 kilojoules. All right, so then I look at what I can cancel, and I can cancel the CO2 on both sides, and I have some O2 on both sides. So that allows me now to add up the equations. So that would give me carbon graphite solid, going to my carbon diamond solid, and then what I do with my enthalpies is I add them up. So my delta H in this case would be 2 kilojoules, all right, and that would be per mole of graphite. So again, we obtain this value simply by summing the delta H values for the equations as shown above. It's an endothermic process since our sign of the delta H is positive. So that is a simple Hess problem I wanted to get up for you guys to take a look at. Let me know if you have any questions.